Hello everyone and welcome back to LearningHub, where we make complex machine learning concepts simple, visual and fun to learn. So today we're diving into one of the most important foundations of machine learning, and that is understanding how data is represented and how math powers our models. So by the end of this video, you'll clearly understand what scalars, vectors, matrices and tensors are, and how data becomes a matrix, and what the famous equation x times beta equals y really means. So without any delay, let's get started. We'll start with a small thing or a small concept, literally. So we'll start with a scalar. So what is a scalar? If we have to define a scalar, it is just a single number. It could be your age, the temperature or the loss value in a machine learning model. Your scalar has no direction, no dimension, it only has one value. So you can think of it as a single point on a number line here. Next, we move to vectors. A vector is simply a list of numbers. Basically, it is a one-dimensional array. For example, if your marks in 3 subjects are represented in this particular way here, so that is your marks vector. What vector has is it has both magnitude and direction, like an arrow in space. Now we'll stack a few of those vectors together, and then you basically get a matrix, a two-dimensional grid of numbers. So imagine a table of students' heights, weights and ages. So each row represents one student and each column represents one feature: height, weight or age. And finally, we generalize this idea to more dimensions, introducing tensors. So tensors are just multi-dimensional container for your numbers. So you can take an example of a grayscale image. It is basically a 2D matrix of pixel values. But if you consider a color image, then in case of a color image, you add a third dimension, basically the RGB channel, making it a 3D tensor. And if we take a batch of image, we basically get a 4D tensor here. Suppose in this example, we're taking a color image with height, width and RGB channel. So the tensor becomes of shape height, comma, width, comma 3. Basically 3 represents the RGB channels here. So if we have to summarize, we can say scalar is in 0 dimension, vector is in 1 dimension, matrix is in 2 dimension, and finally tensors are in 3 dimensions or more. Now that you've understood these building blocks, let's see how real data becomes a matrix in machine learning. So imagine you're studying 3 people. For each, you record the height, weight and age. So each row represents one person here, that is one sample. Each column represents one feature: height, weight and age. Now if we strip away the labels, what we have is just a numerical matrix here. Suppose if we remove these name, height, weight and age titles here, the only thing that remains is this particular X matrix here. So this is a matrix, and then this is how we convert our real world data into a matrix. And if we talk about the shape of this, now this consists of 3 rows as well as 3 columns. So in machine learning, this matrix is called X. Basically it is the input data, and the thing we want to predict, say a person's health score or category, is stored in Y, the target vector. So row are samples, columns are features, X stores your input and then Y stores what you want to predict. Now we'll try to understand using another example. So if we look at this particular example, here the size, bedrooms and this particular feature here are all input matrix. X are matrices and Y are just tensors here, which means X is an input matrix and then Y is basically a target vector of dimension 3. Now we can model the above dataset as a problem. Let's say we want to predict an output Y for some input X. For example, predicting housing price based on the size, number of bedroom and age of the house. So here we've taken some data set. The size is represented as x1, bedrooms represented as x2, age represented as x3 and price represented as y. Now here comes the magic, the math that makes machine learning tick. So in linear regression, we model the relationship between the input as well as the output, and then we model it as this particular form in equation 1 here. So what are x's here? These x's are our feature matrix or the input data. The beta term here is a column vectors of parameters. Those are the weights that the model needs to learn, and then y here is the target output, the actual values we're trying to predict here. So for a single data point, consider this particular first data point here. What we have here is the actual value of y is 20,000, x1 is 1400, x2 is 3 and x3 is 5 here. The value beta naught, beta 1, beta 2 and beta 3 needs to be learned by the model during training. So the model's best job is to find, the best beta values so that the predictions made by the model, which are represented as this y hat symbol, are close as much as possible to this particular y here. And then how do we get this optimal value of weights? Well, in linear regression, we have this normal equation whose formula is shown here as x transpose x inverse x transpose y. And using this particular normal equation, we calculate the best or optimized value of beta, which calculates the best fit line or hyperplane through your data. Okay, so let's recap what we learned today in this video. So a scalar is a single number, a vector is a 1D list of number, a matrix is a 2D grid, meaning which contains rows and columns, a tensor extends that to 3D and beyond. Datasets in ML are represented as matrices, rows are samples, columns are features, and the mathematical heart of linear model is this particular equation here, which is y equals to x into beta, where we predict y from x using the learned parameter beta here. And that's it. I hope you now understand how data transforms from simple numbers into the mathematical form that powers every machine learning model. So if you found this video helpful, don't forget to like, share and subscribe to LearningHub for more fun and visual deep dives into AI and ML. Thanks for watching, and I'll see you in the next one.